Hi students, welcome back to our class. How are you all? I hope you all are fine. Now I am going to teach you subject physics, lesson number 4, simple machines. Students, we know that we have learned in lesson number 3 when we apply the force, stationary body starts to move. So in physics, work is said to be done when we apply the force on the body and body starts to move. And no work is said to be done if no motion produced even we apply the force on the body. So we can say that students, work is said to be done when we apply the force on body and body starts to move, and we can say that no work is said to be done if there is no motion or no changes in position take place even we apply the force on the body. For example, a cyclist pedaling a cycle does a work. A horse pulling a cart does a work. An engine pulling a train does a work. A boy going upstairs does a work. A boy lifting a book does a work. And no work is said to be done if no motion produced even applying a force on the body. For example, a boy pushing a heavy stone, no work is done if no motion is produced even applying a force. Now I will define the definition of energy. A body capable of doing work is said to be possess energy. And students, energy is needed to do work. And in another way, we can say that the energy of a body is its capacity to do work. Now, I will define the definition of machine. Machine is a device which helps us to do work more easily by applying less force and spending less energy. For example, suppose the lid of tin container is tightly closed and we want to open it with the fingers and it does not open, then we use the spoon, and the spoon is inserted between the lid and the edge of the tin container, and we push the spoon from the another side and lid opens very easily. So we can say that the spoon is here work as a simple machine. Another example, suppose you want to open a tight nut and it's very difficult to open with the fingers. So you take the help of spanner to open it. So spanner is used as a simple machine to open a tight nut. Another example, it is very difficult to open the tightly fitted cork on the bottle. So you take the help of screwdriver the screwdriver is inserted in the core, and easily we are able to open the cork from the bottle. So here screwdriver is used as a simple machine. Another example, suppose you want to move a heavy load from one place to the another place. So it is very difficult you to pushing or lifting it from one place to the another place. And if you are using the trolley and you place the load on this trolley, and it is very easy to lift it from one place to the another place. So your trolley is a simple machine. Another examples, in factories a crane is used to lift the heavy equipments. Another example, a bottle opener is used to open the lid of the soft drink bottle. So here bottle opener is a simple machine. Another example, a door knob is used to lock or unlock the door. So here door knob is a simple machine. A pulley is used to pull bucket of water from a well. Another example, a iron bar is used to shift a heavy stone by pushing it. So here iron bar is a simple machine. So in the above examples, here spoon, spanner, screwdriver, trolley, crane, bottle opener, doorknob, pulley and iron bar. These are the simple machines which are used to do work more easily by applying less force and spending the less energy. Now, we will talk about the principle of a simple machine. A machine does not work itself. When energy is supplied to simple machine, it does some useful work. To do work on a machine, a force is applied, and this applied force is called effort. As a result of this applied force, machine also exerts a force, and this is called load. Now students, we will talk about the efficiency of a machine. So, efficiency of a machine is the ratio of useful work done by machine on the load to work done on the machine by efforts. So students, in the other word, we can say that efficiency is the ratio work output on the load to work input by the effort. Now we will talk about the ideal or perfect machine. A machine in which no part of the work done on the machine is wasted is called ideal or perfect machine. In perfect or ideal machine, the work output on the load and the work input by the effort is equal. So in that condition, efficiency of the machine is equals to 1. Now we will talk about the actual machine. In practice, no machine is perfect because some part of the work done on the machine is lost on overcoming the friction between the moving parts of the machine. Students, now we will talk about the functions of a simple machines. So there are two functions of a simple machine. First, it changes the magnitude of the force required. That is, the effort is less than the load. For example, a jack is used to lift a car. An iron bar is used to shift a heavy stone. So, in these examples, the effort needed is much less than the load. Another function of a simple machine is it changes the direction of a effort in a convenient direction and a convenient point. For example, to lift off a bucket of water from a well, we use a pulley, a simple machine. Effort is applied in a downward direction as well as our own weight as an effort to pull the bucket from the well. In this lesson, we will talk about the 6 simple machines. First, lever machine, for example, mango cutter, beam balance. Second simple machine, pulley. Third simple machine, wheel and axle. For example, door knob, steering wheel. Fourth simple machine, inclined plane. Fifth simple machine, the wedge, for example, needle, axe. And the last simple machine is the screw. So students, I hope you understood the concept, work done and energy, simple machine and their examples, efficiency of a simple machine, ideal or perfect machine, actual machine, and the functions of simple machine and the 6 types of simple machine. Thank you so much.